This next chunk of the June 2011 region exam is going from number 62 to 69 in the free response. Number 62, 63 at the top of this page is saying that you have an electromagnetic wave with a wavelength of 5.87 times 10 to the negative 7th meters, and it goes into corn oil, and we want to find the wavelength in the corn oil. All right, and then show work, including equation and substitution. All right, so if we have something going from one substance to another, and then I want to find wavelength, we want to use the N2 over N1 equals wavelength 1 over wavelength 2 formula. So let's just say that air is our medium 1, so 1 is air, and 2 is the oil. Right, so let's set up this proportion with everything we know. We know that the index of refraction for corn oil, that's in your reference table. So your N2 is 1.47 over 1 equals 5.89 times 10 to the negative 7th meters over our unknown wavelength. Okay, this is our wavelength in the air, so we need to put that in for wavelength 1 because 1 is air. And now we just have to solve this. All right. So to solve this, we need to cross multiply and divide, and we end up with wavelength 2 is 5.89 e negative 7 divided by 1.47, and throw that into your calculator, and you should get about 4.0 times 10 to the negative 7th meters. And that is your final answer. All right. Do we show all work with equation and substitution with units? There's the equation. Here is substitution. There's our unit. Final answer has a unit. We're good. 2 out of 2. Next question is asking about the energy required to separate 3 protons and 4 neutrons in the nucleus, and it says that the energy is 39.3 mega electron volts. Okay, here's a little hint. Mega electron volt is MeV, and we want the mass equivalent in universal mass units. Universal mass units is U. So here we have mass energy conversion using MeVs and U's, so we want to use our conversion 1U equals 931 MeV. All right, this tells us that, all right, so let's set up a little proportion. So we have 1U over 931 MeV is equal to X that we don't know over 39.3 MeV. And let's solve for our X. We can cross multiply and divide this, so we get 931 divided by 39.3. All right, so that should be 931 divided by 39.3 equals, no, I did that wrong. That should be the other way around. Ignore that. It should be 39.3 divided by 931 equals 0.042U, and that is your final answer right there. All right, and remember, this number needs to be less than 1. All right, if 1U is 931 mega electron volts, you're dealing with much less than 931 mega electron volts, so you need much less than 1 universal mass unit, so that is much less. All right, this question can be a little challenging if you're not really sure what you're looking at. So this is a set of waves that are traveling through the water, and it's saying you want to draw the waves in the shallow water is as the speed of the waves decrease. Right? So speed of waves decreases. If the speed of the wave decreases, that means that the wavelength is going to get smaller. Right? So a shorter wavelength just means that the lines are closer together. Right? So you just want to draw straight lines that are closer together than these lines. So then this is a smaller wavelength, thus lower speed. And that's all there is to it. All right, this next question, we are using a scaled model, and if we take our ruler, right, we want to measure this this vector here, and I had set this up so it would be what I want it to be. Here we go. So this vector is, come on now, ruler. This vector is 7.5 centimeters long. So 7.5 centimeters is equal to 1.5 meters per second. All right. That means 1 centimeter. We just have to divide that. 1 centimeter is going to be 0.2 meters per second. And that is the scale that we're using here. Next question. It says, using a protractor and a ruler, construct a vector to represent the resultant velocity of your airplane. All right, and I'm going to have to erase this because that's in the way. All right. So because you're using a ruler, I'm just going to go with some straight lines here. And you want to put straight line. No, that's not the line. There we go. You're going to want to do a little parallelogram method here. All right, straight line, and then your resultant vector is going to be this. Make sure that the arrow of your resultant goes right to that edge. All right, goes right to that intersection right here. So that is number 67, and we need to label that vector letter R. Now, according to the instructions right there. All right, it says determine the magnitude of the resultant velocity. Well, the easiest way to do this is probably to do a little Pythagorean theorem. If we know that we have 0.7 and we have 1.5, so we have 0.7 squared plus 1.5 squared equals r squared. Solve for r squared, and r equals 1.7 meters per second. All right, not too bad. And then last one, it says determine the angle between north and the resultant velocity. So to get this angle, you could use some trig if you wanted to. All right, so we're looking at this angle right here. Boom. All right, between north and the resultant velocity. So you have two options. You could say, okay, well, I know that we can use the tangent theta is equal to the opposite over the adjacent. And so we got 1.5 over 0.7, and you could solve it. Theta is about 67 degrees. All right, that would work. You could also bust out your protractor, and then, how do we rotate this guy? No. We need to take our protractor, and we need to line it up on north. All right, there we go. And then we need to measure. No, we want to measure from this side. How do we measure from this side? Oh, there we go. So that right there is at, so there's 60 and there's just between like 65 and 66. So 66 degrees, you have a 2-degree margin of error, so somewhere between 65 and 67, that'll get you your point for that question number 69.